Hello all of you, myself Harshit Srivastav, and I am recording this demo video based on Mensuration class 10th. So let's start. In Mensuration, we obviously the Mensuration word comes from measurement. Here we measure like 2D and 3D figures, like standard figures. Okay, so if we see, I am going with a very basic approach, like how we get the areas and how we get the volumes. So let's start with a very basic approach, like how the area comes, like, and how it is calculated. Then we will go with the figures one by one. So let's see the 2D figures. 2D figures means which can be drawn on a paper, and they have only like two measurements. If I start with a rectangle, so here we have a rectangle. Okay, so this space is created, like which I can like touch and feel this area. So that is called the area of something, right? Area. So how that area is being made, that I am going to tell, and how that is being measured. So like if I draw one line and then again draw another line beside it touching it, and another line beside touching it, and another line, like this. If I draw line by line by line by line, so I am drawing, let's suppose this line which I drawn was of length L, and till where I drawn it till some length Z. Till some length Z I have drawn the line L's. So here the measurement of this, how much area it makes, that is, give the L line is being made Z times, right? L, total it is being made Z times. That's why this overall area can be L into Z. That is how we calculate the area of something, right? That is the area, means the one-dimensional measurement. This is a one-dimensional measurement L, and this is another one-dimensional measurement, that is the Z, or the breadth of the rectangle. So this makes an area. Also, we know area of a circle. Area of a circle, we very well know that it is pi r square, and it comes, how it comes, like we have a circle. If I break it into 4 parts, and if I draw like this, if I join the broken parts like this, then again cut it into some little small slices, then some or the other way I will find a rectangle, right? A rectangle like this on the small slices. Then that rectangle area would be again, that is pi and r. Pi is a irrational, so it is being made with some experimental measurements. So like this we have the area of a circle. So is it clear? Now we know the areas. Now let's define the volume. How volume comes. Okay, volume of something. Volume means how much like quantity of matter can be contained in it, or how much volume of liquid can be stored in some vessel. So that is the volume. Volume is the actual space. Like if I have a vessel, so how much liters of, like suppose, milk can be there. So it's some volume. It is not like a surface area, right? So let me explain you once. See, I have this book. This book has this much of volume. Means if I cut this part, if I make it hollow, then I can store a lot of stuff inside it. So this complete is a volume, right? So the thing is, how I make that volume. Now only I told you that this is a single one-dimensional area. It has some length, it has some breadth, it has some area. Like suppose the last page, this one, it has some, this is one area. I made you clear that it is a length. I made a length L, like that. Till how many times I have made it? I have made it B times. So this is L into B. This is the area. Now if I keep another L into B area upon it, then again one L into B area upon it, again one L into B area upon it. Like this, if I keep on making one more area, 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 then what happened is I got a volume. Can you see? this is the volume. If I make it a hollow, like if I make it a plastic box of this size, that would be hollow, and inside that plastic box I can keep a lot of stuff. That is the volume of this complete box or this book. If I cut these pages in this shape inside it and make a space, that would be the volume. So how we got the volume? We made one area, kept another area, and like that when we kept adding on area, till when we add area, till this height we added some area, right? So let's continue. Now I have an area L into B. I kept on adding L into B again and again, keeping one over the another till the height H, right? Then I got the volume. So this is how this happens. Okay. So if I keep L into B, this is some rectangle area, and keeping another heights upon it, till how much height? Till H height. So it makes the volume L into B into H. So this is how the formula of volume comes. That is कि हमने नीचे में बेस जो रखा, जो पहला पेज रखा, उसका एरिया कितना था? L into B, that was the area. और हमने उस एरिया के ऊपर एक और एरिया रखा, कब तक रखा? Till the height H. तो how it comes? Area of base into height. Okay. So the total volume of anything comes when we multiply the base area upon which we keep another base area, another area, and till some height H. This is how it comes. Now this can be done for a cuboid, like a simple cuboid. If I have this cuboid in any time in the life, if I see the cuboid, what I would try to say, it has some base. The base has some area L into B, and how many L into B are kept? Till height H, there are n number of L into B are kept. So I will simply multiply this base area by the height. That would give me the volume. Is it simple? Now if I see someday that I have a cylinder, like this is a cylinder. So what I would see? I would see what is the base. Base is a circle. So again, what is the area of base? Area of base, this shape is a circle. Hence, the area of a circle is pi r square. Am I clear? So this pi r square is our area of the base. Now, this pi r square, then again I kept one more pi r square, again one more pi r square, again one more pi r square, that I showed with the textbook, like that, till the height H. I have kept total these many pi r square till the height H. So multiplying with the height. So this is the base area into height. This is simple. So this is the volume of a cylinder, which is, we have learned, pi r square H. Isn't that simple? So like that it comes. Now going with this, we talked about a cuboid, we talked about a cylinder. Now it's time of talking about I should talk about a cone, right? We have seen cones in life, like this we have a cone. So by observation, what we found, that when we have some cylinder which has a radius r and it has the height h, and when we keep a cone of height h inside such a cylinder, like it touches the bottom, like this, we have a cone here, and cone's height is also same as the cylinder, that is h height. Then what we found, that if we fill the cylinder with water, okay, if we keep this, fill this with water, and now put the cone inside the water, some water will displace, some water will come out. Okay, so what we found, that the water which comes out, that is the volume of the cone. Obviously, how much the space the cone will use, that much water will come out. So that water is only 1/3, that is the 1/3 of the height of the 1/3 of the volume of the cone, so of the cylinder. So hence volume of cone is 1/3 of that of a cylinder, and volume of cylinder जो कि हमने बस ठीक पहले पढ़ा था, which was pi r square h. So here our demo ends.